Okay, today we got capacitor off of a the AC unit downstairs. If your fan motor or compressor stops working suddenly, this is very likely your prime candidate. They're cheap. This one's about $8. It's for the main fan for the house. In this case, I just went ahead and replaced it because I was in there doing some work already anyway, and for the sake of $8, you know, why the heck wouldn't you just go ahead and replace the thing? So let me get something to draw on. There you go. Good as anything. Okay, so the way a capacitor works is essentially you've got two plates, a positive and a negatively charged plate that are brought into close contact with each other, and depending on who you talk to, electricity flows negative to positive, positive to negative. Conventional, we just say positive to negative, even though the electrons are the negatively charged ones, and the positive is actually a lack of electrons, so electrons actually flow negative to positive. That's electron theory, but we'll go with conventional theory for all you conventional types out there. Wouldn't want to be unconventional. So the electrons, and in between here is an electrolyte, and the buildup, and you've got a circuit, right, with some sort of resistor. We'll just make like a little light bulb here. Bing. Okay. So the electrons will flow positive to negative just because they're separated by this insulator, and they are attracted to the negative plate, but they have no other way to get there. So they will circulate around. I think that's an okay way to explain that. Now, these are on AC motors. They act as a... not really a resistor, they act to delay the one of the phases to give you 220. And sorry for the red hands, it's kind of cold out here this morning. But so normal AC goes back and forth, right? 120 volts. So what this capacitor does is you'll send the electricity through here and it will offset a phase, because what it does is it acts to delay the electricity, and what that gives you is two phases to run a motor. So usually a little bit higher powered 120 volt, well, a little bit higher power motors in residential applications, any sort of like home application where you don't have three phase off the shelf, they need some way to offset one of the phases to give you to create an induction motor, so you don't have to have any brushes, all that kind of stuff. They can do that with a capacitor. They can do that with a shunt winding. The newer systems now use variable frequency drives. Like there's new well pumps now that use variable frequency drives. Anyway, all that aside, that's pretty much what you need to know. So you got two plates, electrolyte. Because they're close together, the electrons want to hop across, positive to negative. And in most, residential type applications or any sort of home type situation where you don't have three-phase electricity, this is going to be used to offset a phase of the electricity coming out of the wall to give you three phases. So all I'm going to do here is I'm just going to cut off the top. On the top here, we've just got the positive, well, who knows which is which, positive and negative terminals. As you can see, these are rated in farads, 10 micro, I think that U is the micro farad. So it doesn't take a whole lot. Like I said, this isn't really storing any energy. All it's doing is delaying the one of the phases of the AC. So I guess I'll just cut off the top and we'll see if we can look inside. Need a bigger bandsaw. Ain't no kill like overkill. Ugh. Got some juices leaking out here. All right, so what's leaking out is most likely the electrolyte. Ooh. Good thing we got the cardboard, huh? All right, so what's leaking out here is the electrolyte. You can see 2 leads going in there. More than likely, this is just like a dielectric grease. That's probably all that is. All right, so we got positive and negative leads here. Got a little shield. And of course, we've got something else to cut open. All right, so nothing to the housing here. There's an insulator in the bottom there, you can see. So that just plastic, it looks like probably nylon to keep it from going. This gel probably is, well, it's an electrolytic gel for sure. It's not conductive. I can prove that to you. Give me just a second. All right, so that's in there, nothing. All right, so not conductive, conductive, not conductive, even if I get real close to it. Ew, gross. All right, I'm gonna clean this off. Get some of the schmoo off. All right, and hopefully everyone's good with all this because it's going away and we're just gonna keep this little piece here. All right, so this little piece should be, we'll just cut it open as well. Let's do a slice this way. I don't immediately see, like I would think that this reflective stuff would be foil. Yeah, okay. So this is multiple layers here. So you can see how that has multiple layers of foil and insulators. So that's how you get the capacitor. So in this case, you know, I described the 2 simple plates next to each other. In this case, they're all rolled up into a bundle around one another. And I doubt we're going to be able to figure out what's what, because it's kind of hard to tell. Like there's this plastic stuff on top of them, and it's really hard to tell when you've got the plastic off of the metal inner layers. Yeah, see, like even there. Doesn't want to go. But anyway, there you go. That's inside of an HVAC capacitor. So thanks for watching.